Astronomy and Astrophysics class for IOQA students. Just get me a second as I just have to open this in my phone so that I can read your comments. Otherwise it will be difficult for me to read your comments. Just get me a second. So since this is a first class and yeah, I did it for the first time on my own, and so this happens. So let me just copy and just paste it here, paste the link. So I hope you guys can see this thing. Wait, I'm not able to see whatever you guys are writing, so just get me a second. Okay. Yeah. You guys are able to join the video and I'm not able to join the video for some reason, some strange reason. Can college students participate? Of course, yes. Anybody can participate here. No issues. Okay, so guys, it might take me for if I have to read something, I have to come back, get back to another screen and read it because unfortunately it's not opening on my phone. So what I will do is I'm gonna just quickly start the session today, and then maybe we can discuss on one-on-one, and if you have any questions I would be happy to answer those things. Okay, all right, let's get started on today's class. So this will be mainly based on the astrophysics program for NSEA and IOQA students. Okay, so here we are gonna learn these things in detail. Okay, so let me just quickly take my pen, pointers option, pointer option, ballpoint pen, and let's start. Let me just quickly take my pen. Okay, actually I had continuous classes and so I did not keep things stuff here. Okay, so let's get started. So this will be based on astronomy and astrophysics. Okay, this will be for both NSEA and Olympiad exam students. It will help you guys. Okay, so I'm gonna complete those syllabus for that particular elementary astronomy needed for clearing the examinations. So let me just quickly see if any questions have popped up. So let me just keep this and let me see anything. So anything you wanna ask, you guys can ask me, because yeah, this is how I'm streaming right now with the OBS. So any questions before we begin? Anything you wanna ask? So we are gonna start soon. Okay, because it takes for me for a while to look at your chat for some strange reason. So if you have any questions, you can put it up here in the chat box. Okay, if there are no questions, then we are gonna get cracking on this particular class. So the in this particular topic, what does the word astro mean? What does the word astro mean? Astro means star. Okay, astro means star. Many people think it's space, but it's star. Astro means star. So learning is basically you are applying certain measurement techniques to understand them in detail. Okay, so here since we are talking about stars, so we need to understand first what is a star, like what are the physical properties of the star. What are the physical properties of a star? What are the physical properties of a star? And then we have to look at there are many physical properties which we will go one after the other. So physical properties of a star to begin with. Then observational techniques. How do we observe these things? Observational technique. What are the observational techniques we are gonna use to understand them in detail? And also we are gonna study the main aspects like what are the coordinates, like we have celestial coordinate systems. So we are going to study the coordinate system or positional astronomy, we call it as coordinate system or positional astronomy. Positional astronomy. So this is just an introductory class. Okay, so I'm not gonna straight away go into the details of these things straight away. So today we are gonna just have the basic introduction to the physical properties of the star, and maybe few properties we are gonna study on the way. Let me add few slides. Let me just escape this. Kindly make the notes as we go along so that we have enough. Okay, so let me just make this note. I'm gonna use like a whiteboard and a marker kind of a technique, which is comfortable for me. So the physical properties of the star, when we talk about physical properties of star, so we are going to study the main properties. Like when you look at a star, what is the first thing that comes into your head? So you see how bright or shiny the star is, right? So we call that as luminosity. We are going to understand how luminous the star is. Okay, luminosity, we are going to understand the luminosity of star. Then we are going to continue with brightness. Okay, in brightness we measure the brightness using a technique called as magnitude, and we have two types of magnitudes. One is called as apparent and another one is called absolute magnitude. Apparent and absolute magnitude. And when we have volumetric magnitudes and other types of magnitudes of measurement. I'm gonna go in detail what they are once I go one by one, step by step. So then we are gonna study the distance measurement, which you would have studied in class 11, parallax technique. So distance method for using parallax technique. Then we are gonna study the surface temperature of the star. How do we measure surface temperature of a star? And we are going to look at the size of the star, or you can call it as radius of a star. And also we are going to talk about a little bit about how do we find mass of a star. So this will be the basic introductory part of how these things are going ahead. So you guys can even ask me in the Telegram group also the questions. If you have any questions, like you are doing chat, right? That chat, if possible, if you can do it in the Telegram group, that will be helpful for me, because I can see if possible. If not, I'm gonna try to look at it. Let me just take a second and look at if there are any questions that has popped up here. Okay. Hi. Oh, Parth is here. Okay, so we are gonna study these things, and then looking at the properties, we are gonna go ahead yeah. So all the batch people are here. I can see. Okay, I can see quite a few are here. Not everybody. So quite a few of you who are really serious are here. Maybe some of them are busy a little bit, maybe. Now what we are gonna once we complete this particular parameters, I'm planning I'm gonna teach you the positional astronomy along with the stellar properties. So we have something called a celestial sphere, then spherical coordinates, all these things. Who can participate for this Olympiad? Any class 12 students can participate in this Olympiad examination. It's just like Olympiad in physics, chemistry, maths and biology. We have IOQA, International Astronomical Olympiad Qualifier Examination. For that, first you have to write in the national levels, get selected, and then go ahead with it. Or you had a class and you still joined. That's very sweet of you, Parthji. Okay, all right. So yeah, here we are. So we are. Let me just zoom this. So we will go one by one. First is the luminosity part. Let me just pointer option. Yeah. So when we talk about luminosity, of a star, so we are gonna start with the definition. So star does not mean like this. So all of our school day stars looks like this, no? So we don't think stars like this. They are basically giant ball of gas. Okay, giant ball of gas, just like our sun. And we have different classification of stars, which I'm gonna talk at the end of this particular lecture. Okay, so when we talk about luminosity of the star, the main parameter here is how much energy or flux is coming out of this particular star. So imagine this is a star. So what happens inside? Thermonuclear fusion reaction, right? Thermonuclear, these are basic stuff. Nuclear fusion reaction takes place. Basically, if you take our sun as an example, you see hydrogen and hydrogen are fusing to form helium, and so on and so forth. Proton-proton cycle. And for much heavier masses than our sun, there is something called as CNO, carbon, nitrogen, oxygen cycle, which is being used to understand the thermonuclear fusion reaction in heavy mass stars or very huge stars. Okay, so basically it's a big sphere of spherical gas ball which has thermonuclear fusion reaction where radiation pressure is pushing everything outward. So in the star, the radiation pressure, because of this reaction, everything is blasting, like nuclear bombs are going off and everything is blasting, and the radiation pressure is going out in the outward direction. And there is something called as gravity, which is pulling everything inward. Gravity is pulling everything inward, and the thermonuclear fusion radiational pressure is pushing everything outward. So this balance of radiational pressure and this gravity, this particular situation, this particular condition, we call it as hydrostatic equilibrium. Okay, my pen. This is called as hydrostatic equilibrium. Sorry, yeah. My pen doesn't write properly sometimes. I think, yeah, this is the eraser. Okay, where are you, Mr. Pen? Okay. Hydrostatic equilibrium. Okay, so this hydrostatic equilibrium is the balancing part. Now one interesting aspect of it is studying luminosity. Luminosity is how much energy or flux is coming out of this star. So what do you mean by flux? Flux means, imagine this is a sphere and how much energy is coming out of this particular area of the sphere. So that we call it as flux. So it is the amount of energy passing through the normal of this particular surface, through the normal in unit time. Okay, if you consider certain time, how much energy is coming out of that surface, you call it as luminosity, and it is represented as L. Okay, so what does it say? If you want in English definition, you can just write it as it is the amount of energy. It is the amount of energy passing normally. Energy passing normally through its surface, in unit time. This is the definition of luminosity, and it is represented as L. And for sun, we always put a circle and put a dot. That means this is the symbol that we are measuring for sun. Okay, if this symbol is used, this is for sun. So the luminosity of the sun, L0, is approximately equal to 3.9 into, what happened to my pen? Okay, it's back. 3.9. I am not able to see anybody's chat because of this particular issue today. From the tomorrow's class, I think I'll be much better equipped with the equipment. 3.9, 10 power 26 watt. Watt is the unit used for luminosity. Okay, so this is the luminosity of our sun. So I hope this is clear. Any doubt so far? You guys can ask me. I'm gonna just pause here for a minute, and if you have any doubts, yeah, hi Om Narayan ji. Hi, somebody named Good and Verified Cryptos Airports have joined. All right. So, any doubts so far? Any doubts? I have just paused for a minute to ask if there are any doubts or anything that you want to ask. Can the college student participate? Yeah, they can. Metaphysics. Mathophysics. Okay, mathophysics. Your Om 2.0. Oh, hi Om. Hello Ji, namaste. Hi. Okay. So, any doubts? Any doubts so far? You have and you wanna ask later, I believe. Okay. So, okay. Okay, majority of you have joined, I think. I'm seeing, yeah, seeing people are increasing. Okay. Yeah, I'm an astrophysicist. I'm an astrophysicist from Bengaluru. I'm a young scientist awarded from Indian Science Congress and a young researcher awarded from European Space Agency, Netherlands. And also, I'm an author of a book. Yeah. So yeah, you can yeah, you can look Google me, Amazon me to find more details about me. So that's about me. Okay. So you and also okay, where am I? We will go for the next topic, which is the brightness. Next property, which is the brightness. So if there are no doubts, I'm gonna go for the next property, which is the brightness of the star. Brightness of a star. So what is the brightness of the star? When we talk, we talk about two things. So in order to find the apparent brightness of a star, we just say brightness is equal to the ratio of luminosity by area. Area we know 4 pi d squared. What is d here? D is the distance of the star from the observer. D is the distance of the star from the observer. Arey yaar, my pen. Distance. Today star from the observer. Okay, so if you want to just get the feel of numbers, in order to find the brightness of the sun, I told you have to put circle and put a dot for sun. So luminosity of the sun divided by 4 pi d squared. Okay, we know what is the luminosity of the star. I just gave you those numbers, which is 3.9 into 10 power 26 divided by 4 pi. What is the distance between Earth and Sun? So the distance between Earth and Sun is 150 million kilometers, or 1.5 into 10 power 11 meters. So 1.5 10 power 11 whole square. So the number we are gonna get here is 1370 watt per meter square. This is the brightness of our sun. Okay, this is the brightness of the of our sun. So this is for sun as an example. Okay, so you can find all these details even in my book. So for all those details, you can ask me in Telegram regarding the book link and everything if you are interested. Okay, all these are available as notes there, so you can use that. Let me just add some slides. Okay, so okay, where am I? Let me right click and get this. Okay, now I told you at the initial part of the discussion. So brightness is measured using a concept called as magnitude. Okay, in this we have two types. one is called as apparent magnitude. So we are going to start with what is apparent magnitude. Apparent, what is apparent to us? Okay, when we talk about apparent magnitude, what is apparent to our naked eye? That's what apparent means here. Apparent magnitude of the star, which is represented by small m. Apparent magnitude of the star is represented by small m. So if you have to just give a simple definition, it is a measure of brightness. It is a measure of brightness of a star. That's all. Okay, it is just a how do you measure the brightness of a star? So imagine you are having only naked eye. You forget about telescopes and everything. Okay, you just have a naked pair of eyes which is working. Okay, let us imagine there are two eyes and which are working properly for us. And when this is working properly for us, when they started when the ancient people started measuring this apparent magnitude, so what they did, they called the brightest star to have the magnitude 1. Okay, this is for the brightest star. And as the dimness of the star goes by, the dimmest star from our naked eye observation was, if you are a very good astronomer and the sky is very clear and there is no air pollution, light pollution, you need that. For killing light pollution, you need not go and kill all the street lights today. Don't do that. So these magnitudes varying from 1 to 6, 1b, first rank student is the brightest student, no? So going from 1 to 3 like that, we go up to the dimmest level of 6. Okay, so this is how the eye adjusts itself to measure the brightness of the star. Once they created this scale, people started wondering, what about sun and other things? But they wanted to keep one standard star as Vega. Okay, we have a star called as Vega, and the magnitude was set to be 0 for star Vega. And before Vega, there are much brighter objects, right? So they kept this as a standard, but they wanted to know what is the the brightness of the sun and moon are much brighter than these stars. So what they did, they went for a negative scale. So minus 26 approximately, I'm writing magnitude of minus 26 odd for sun, and for moon around minus 12. I'm writing approximately. Okay, so these are the range at which for moon and sun was understood. Okay, so once they created the first rank, second rank system, they forgot about the bright objects and then they revisited and they got these things. So these are the magnitudes that you can measure using our naked eye, which are in a standard distance which is visible to us. Okay, so this is for our naked eye observation. Naked eye observation, this is very much important. This is a scale we use for naked eye observations. Okay, so there is another magnitude called as absolute magnitude. Absolute magnitude. So since this is these are related to examinations, I think I should give you equations as well. I always feel equations play a major role in physics, and any competitive exams does require you to understand these concepts using equations. So if you want to find magnitude between any two stars, apparent magnitude between any two stars, so the formula will be m1 minus m2 is equal to minus 2.5 log 2 base 10 brightness of the star 1 divided by the brightness of the star 2. Okay, this is the formula that we are going to use to measure to find the difference between magnitude or brightness of the star relationship. Okay, why did we use logarithmic scale? Because our eye response curve works with the logarithmic scale. That's the reason logarithm is used in this particular context. Okay, because our eye, if you look at the way the eyes look at the object and how they understand, they follow this particular trend. Okay, then we have something called as absolute magnitude of the star. Absolute magnitude, which is represented by capital M. Okay, apparent magnitude was represented by small m, absolute magnitude is represented by capital M. Okay, so how do we define this? So you can just say it is defined as, it is similar to apparent magnitude. It is defined as the apparent magnitude itself, but it is defined as the apparent magnitude, okay, of the star when placed at a standard distance of 10 parsecs. Distance of 10 parsecs away. Parsec is written as PC here, okay? 10 parsecs away. Parsec, okay? Parsec is written as PC. This is on unit. You know, 1 parsec is equal to 3.26 light years. This is a distance scale. So what we are saying, the stars which are far away, we are bringing it to a standard distance of 10 parsecs, and we are defining it as absolute magnitude. Okay, so where is that one? Distance of 3.26 light years. Arey yaar, my pen is not writing. What happened to my pen? Light years. Okay, so you can convert them into meters, you can convert light years to meter, all those things. We can look at it when we are measuring, when we are trying to understand the distance scale. Okay, so this is how absolute magnitude, it is defined as the apparent magnitude of the star when placed at a standard distance of 10 parsec. This number is key. Okay, this is one of the standard numbers. So how do we find the difference? M1 minus M2 between any two, absolute magnitude between any two stars. So minus 2.5 log 2 base 10. Okay, so we are gonna write it as luminosity ratio because both of them distances are same. So when you take brightness B1 by B2, area will get cancelled because distances are same. So the luminosity 1 by luminosity 2. I hope you are getting this point. Very easy. Where is this my pen? L1 by L2. Why did I change B1 by B2 from B1 by B2? Why did this become L1 by L2? Is B1 we know it is L1 by 4 pi, distance is 10 parsecs. So divided by B2, if I do, which is L2 by 4 pi d 10 squares are there. So this is same basically. So L1 by L2 is used here. Okay, so this is how we find, and remember this is base 10 not E. Base E, if you convert base E, it will be an exponential. If you convert base 10, it will be 10 power, right? So you should be aware of that simple mistakes what people do when they are doing calculations. You should remember this is you are not converting logarithm to exponential, you are converting this logarithm to 10 power. So if I have to write this, for example, let me show you in the next slide. So you can write, if you want to find luminosity ratio out of it, L1 by L2 will be equal to 10 power minus M1 by M2 divided by 2.5. That same equation can be rewritten like this. Okay, this is 10 power, not exponential. This is not natural logarithm but to base 10. Okay, so this is how we understand magnitudes. So I would like to just come back and look at if there are any questions right now. Okay, sorry about the screen changes. Okay, sir, objects like asteroids, Earth reflect light. How can you measure the reflected light or re-emitted by them? So you are talking about reflections. So these are magnitudes are used for self-luminous objects. Stars are self-luminous objects, whereas these asteroids and other forms are basically when we talk, they are basically reflecting light. Okay, we usually look at the luminous objects, like how they are illuminating and how these things work in that context. Okay, so that is one of the. So any other questions? Yeah. Any other questions, guys? What I'm gonna do is I'm gonna quickly share my. Okay. Can Path or somebody share my Telegram link? That will be nice. If somebody can share the Telegram link in the chat box, I will pin it in the top of the chat box. Can somebody pin it? Can somebody paste my Telegram Astro group Telegram link? Oh, you are a BSc Physics student. I will tell you how to become an astrophysicist and all as the days progress. Today is the first class, right? To actually every Friday and Saturday we are conducting this particular sessions. Okay, every Friday, Saturday from 10 p.m. to 11 p.m. We are conducting these sessions for Astronomy Olympiad and all these examinations. So all these questions I will answer: how to become an astrophysicist, all those things. We will down the lane. We are gonna answer those questions. Okay. Yeah. So can somebody post my Telegram link? Parth, can you do the honors? Or Om, or Abhilasha, or good and verified cryptos airports personality can put the Telegram, so you can message in the group, and if there are any questions, I will be happy to answer your questions. Okay, anybody? Arey yaar, nobody is posting. Anybody? Maybe I'll come back and look at it if there are any links in the later phases, so that people who are new here can just join the Telegram group and they can get the links of the class. Okay, whenever I am about to post, they will get a notification, or you can press the bell icon to get the notification whenever I come live. You guys will get to know when the classes are. Every Friday, Saturday, 10 to 11 p.m. is the live class. Okay. Okay, now we are gonna continue with where I left off. So this is how the absolute magnitude works, and we have something called as bolometric magnitude also. That is to measure the apparent magnitude of the star for the total rate of energy output from. Okay, at all wavelengths we can measure. For bolometric we can measure at all wavelengths. Okay, like infrared, UV, all wavelengths. Okay, now let me go to the next slide. Okay, pointer options. So we talk about distance modulus relationship of a star. Distance modulus relation of a star. How do we find the distance modulus relationship of a star? Okay, this is the question. So consider a star of apparent magnitude m. So m apparent magnitude, you can just write it with one star if you are writing. So it's constant c minus 2.5 log 2 base 10 L by 4 pi d square. This will be the equation for apparent magnitude. And for absolute magnitude, c is equal to c minus 2.5 log 2 base 10 L by 4 pi 10 parsecs square. Okay, so you do m minus m. Okay, so we subtract equation 1 by the second equation m minus m. You subtract both, you will get minus 2.5 log 10 square by t square. Okay, which is equal to, this 2 gets multiplied. If you take it as a whole, this becomes 2, and 2 into 2.5 will become 5, so minus 5 log 2 base 10 square by d square. And we go to the next step, which will be m minus m, and sorry, I have to this 2 got multiplied, I need not rewrite it again, sorry. Yeah, I wrote it with Josh. Okay, we just multiplied that 2 into 2.5. Okay, pointer options. Okay, so where am I here? Okay, so now this can be rewritten like this: minus 5 log m by n is m minus log n, so log 10 minus log d. Okay, so base 10 you can write here. Okay, this can be rewritten as 5 log d minus 5. I'm just rewriting this way, or m minus, so this will be the m minus m equation. This is called as distance modulus relationship. Small m minus capital M is called as distance modulus relationship of a star. Okay, so there is a distance measurement of the star using parallax technique. All these techniques are gonna be taught to you tomorrow. I'm planning to continue that in the next session, because I think it's already, yeah. So next session I'll be planning to do all those things, and also we will solve some problems regarding all these concepts in the upcoming classes. So if you have any questions, I would love to answer them all here. So if you have any questions, kindly do let me know, and yeah, you can tell me. What about people who use concave lenses? Means when I say two eyes are not proper, no, that's not with respect to any tools. I meant without any telescope or any of those concepts. Okay. Any doubts, guys? Any doubts so far? So if there are no doubts, you can join. You can find me on Unacademy and use my referral code MDK10 to get all the benefits of the Unacademy. And yeah, and these classes will go on. This is just like I'm planning to do it as a hobby for every Friday and Saturday nights. So if you like this kind of videos, please do let me know in the comment section, and please do subscribe and share these videos to make the YouTube algorithm happy. And yeah, we can do all these things, and also we will do more problems. And this is a very basic session, and from next session onwards I will try to make sure that my OBS is working properly. I know this is kind of went way out of my hand, so we will make sure that all those things are intact when we start the next session. Okay, this is Madhukeship signing off. See you tomorrow around 9 p.m. Sorry, 10 p.m. to 11 p.m. Take care. Bye bye.